So this is the first question 1, the first FRQ in your packet. Please, please, please try it on your own before you look at this video. If I see anyone whose answers are identical to mine, I'm not going to be very happy. This is to help you. I am trying to help you learn. It's not going to help you to just copy my answers. For this first one, so in this case, they gave us a computer output. We needed to know how to read it. Remember, this number is the y-intercept. This number is the slope. This is r squared. If we wanted r, we'd take the square root of that, but as a decimal, so the square root of 0.7333. Remember, it can be positive or negative. It'll be the same sign as the slope, so it would be positive. We use these numbers for regression inference. We never use r squared adjusted. So let's jump into it. For part A, it asks you to determine the y-intercept, or it just says the intercept, but it means the y-intercept for the least square regression line. This is not something we've done as many times, but it's still an important interpretation, just like all of the others. So the y-intercept is where it crosses the y-axis. So that's where x is 0, and then y is the value of whatever the y-intercept is. So to write that out, when there are 0 customers ahead of you in line, the predicted wait time to finish checkout is 72.95 seconds. Make sure you have some sort of modifier there, like predicted or on average. That's what their example answer has. It says the average time instead of the predicted time for no other customer. So it did that part at the end, but these are the same thing. I can look at the scoring down here. I need the following 3 points. Correctly identified 72.95 is the y-intercept. I did that. Communicates the concept of y-intercept as a context that includes both time and 0 customers. So I had 0 customers and I talked about time. Indicates the value of the intercept is a prediction by using words such as predicted, estimate, or average. So I did use the word predicted, so I had all 3 things, so that would be an essentially correct. If you were missing one of those things, like if you were missing predicted or you didn't talk about one of the other things, that would be a partially correct. Okay, here's some notes down here. So just writing the equation would not be satisfactory. They wanted to make sure you identified the y-intercept. If you wrote 72.95 in your interpretation, you did identify the y-intercept. If you interpreted 72.95 as a slope instead of a y-intercept, you would not have gotten credit for 1 or 2, which means you would have gotten it incorrect. For part B, it asks you to determine the coefficient of determination. Remember, coefficient of determination is r squared. It tells you that here, but it might not tell you that later. The correlation coefficient is r. So coefficient of determination, r squared, correlation coefficient, r. So to interpret that, 73.33% of the variation in wait time can be explained by the relationship between number of customers in line and wait time. So they interpreted a little bit different, but the same thing. The value indicates the 73.33% of the variability in time it takes customers to finish checkout, including waiting in line, can be explained by knowing how many customers are in line in front of the selected customer. But that's really the same thing. So let's look at what they're looking for. We had to correctly identify 73.33%. I got that. Provide a correct, possibly generic interpretation of r squared. I did that. Interpretation includes context. So I talked about wait time, talked about number of customers in line and wait time, so I got that component as well. All 3 is essentially correct. 2 out of 3 is partially correct. if you reversed the two roles, so if you said the variation in number of customers in line, so if you started with that variable, then that would be a partially correct. Here's some equivalent formats you can read through. So make sure you didn't say predicted wait time right here. But ours looks like it's most closely related to yeah, ours is like this first alternate interpretation. That's what our typical interpretation is. For part C, so you should have circled that point right there. The point that was at about 3, and then I don't know what number that is. And Y close to 0. This point is considered an outlier because of the combination of X and Y differs from the pattern of the rest of the data. Specifically, the value of Y is much lower than what we would expect when X equals 3. So that's what they said. I said this point is an outlier because it's far away from the LSRL relative to the other points. To get credit, essentially correct if you correctly identified the outlier, which I did. If you describe an unusual feature of the identified scatter plot relative to the remaining points, for example, the value of Y is much lower than we would be expected, or the residual is unusually large. Make sure you compared it to the other points. So it's a large residual relative to the other points, or it's far away from the LSRL relative to the other points, because far is a very broad term. They could all be far from the LSRL depending on what you think of as being far. So I need to make sure I compare it to the other points, which I did, so essentially correct. If you got all 3 E's, this is of course a 4 out of 4. If you got 2 E's and 1 P, that's a 3 out of 4. 2 E's and an I is a 2 out of 4. 1 E and then an EP, so this would be an EPI. Let me see, I can write on the screen. So this is saying, nope, okay. EPI or EPP, and then, or 3 Ps. All of those ways get you a 2 out of 4. And then the last one part essentially correct, and then no parts. So an E and 3 I's would be 1 out of 4. If you got less than that, that is a 0 out of 4. And you need to review regression a lot more before you continue. Okay, so go ahead and write your score down for this one, and then you can move on to the next one.